Welcome to Knowledge Base. Let us look at this question. It says a battery of two cells joined in series supplies current to an external resistance of 5 ohms. If the EMF and internal resistance of each cell is 0.6 volts and 3 ohms, respectively, calculate 1. The current flowing in the external resistor, 2. The terminal potential difference, PD, and 3. The lost voltage. So let us represent this information in form of a circuit diagram to aid the understanding. So we have a battery that has two cells. Cell 1 has 0.6 volts, cell 2 has 0.6 volts to form the battery. Each of the cells has an internal resistance of 3 ohms each. So we've represented the battery as this in our circuit diagram. The battery produces the current or the voltage across the external load of 5 ohms. The current flows in this direction through the external resistor. We are told to calculate number 1, the current flowing through this external resistor of 5 ohms. So let's look at the parameters. The total EMF of the battery is equals to 0.6 plus 0.6 because there are two cells, and that gives us 1.2 volts. The total internal resistance R, small letter r or lowercase letter r, is equals to 3 plus 3 because there are two connected in series according to the question. So we add the total internal resistance to give us 6 ohms, and the external resistance R, uppercase letter R, is given as 5 ohms. We have to calculate the current flowing through the number 1 part of the question. So number 1 says calculate the current, and the current is equals to the EMF divided by the total resistance, external plus internal. This is Ohm's law, where current is equals to voltage divided by resistance. In this case, the voltage is the EMF of the battery divided by the total resistance of the circuit, which is the external resistance plus the internal resistance. So if we put the values into it, we have that I is equals to 1.2 for the total EMF divided by 5 for the external resistor plus 6 for the internal resistance. And that gives us 1.2 all over 11, and the current flowing through the circuit is 0.109 ampere. Now let's look at the second one, the terminal potential difference. Number 2, the terminal potential difference. The terminal potential difference is the voltage that is applied just across the external circuit, which is the 5 ohm resistor. It is the voltage which the batteries offers at the terminal of the circuit to flow through the external part of the circuit after whatever voltage that is lost in it is removed. So we are just looking for the voltage across the external circuit, which is the 5 ohm resistor. That is number 2. We know that the voltage potential difference is equals to current times resistance according to Ohm's law. The current is given as 0.109, while the external resistor is given as 5. So this times 5 gives us 0.545 volts as the potential difference or the voltage across the external circuit. Now let's look at the third one, the lost voltage. The idea of the lost voltage is that because the battery also have some internal resistance, which we have identified as theory and theory, it means that it resists some part of the current that is able to produce to the external circuit. Those current that is lost in the battery is what we are calculating for as the lost voltage. So to obtain the lost voltage, we therefore subtract the terminal potential difference, which is the voltage across the external circuit, from the total EMF of the battery to know how much of the voltage is lost within the internal resistance of the battery. So the lost voltage is equal to the EMF minus the PD, and that is, we calculated the EMF previously as 0.6 plus 0.6 to give us 1.2 minus the PD 0.45, 0.545 to give us 0.655 volts as the potential difference across the external circuit, as the lost voltage in the battery. The lost voltage also means the voltage across the internal resistance of the battery. So you can calculate the lost voltage as the current times the internal resistance, and that will give us 0.109, which is the current, times 6, the internal resistance, to give us 0.654. So it's the same thing as this. So you can either calculate the lost voltage by multiplying the current times the internal resistance, or you calculate the lost voltage by subtracting the terminal potential difference from the total EMF. And I hope that is clear enough. Please try this a battery of EMF 12 volts, and internal resistance of 1.5 ohms. Supplies an external resistor of 3 ohms. What is the voltage lost in the battery? Please put your answer in the comment section, and thank you very much for watching.